This is the sketch for Project 5. You can see at the top of the sketch it includes the servo library, and then it initializes an instance of the servo, in this case my servo, and then it initializes 3 different global variables. In the setup function, it initializes the servo and attaches it to digital output pin 9, and then it starts the serial communication. Then in the loop, you can see that it reads the value of the potentiometer and prints that value to the serial port, and then it maps the value of that to a value that the servo motor can read, in this case 0 to 179, and then it prints that value as an angle to the serial port. And finally, it writes that value to the servo using the last command, and it delays it 15 milliseconds. So then here at the bottom, you can see the feed from the serial port, and here is the actual circuit. So if I turn the potentiometer, you can see that it turns the servo, applies, turn the potentiometer, you can see it updates the values here. So this is the sketch for Project 9, and at the beginning it initializes 5 global variables, and then in the setup it specifies the inputs and outputs, and in the loop it records the state of the switch, and then it also records the state of the potentiometer that I've added to the circuit, and then it outputs the speed to the motor if the switch is high, and if the switch is low, then it makes the speed to the motor low as well. So it basically turns the transistor off. So yeah, I added a potentiometer to control the speed in the circuit, and it just is connected to A5 in the circuit here. So I'll demonstrate it here briefly. So if I press the pin or the button, then it will work. If I release the button, it turns off, and then I can vary the speed with the potentiometer. Works really good. Thanks. Hi, this is for Project 10. So this sketch is the longest and takes a little more focus to understand what's going on in this sketch. And this is for the H-bridge circuit for the motor. So you can see at the beginning there's a lot of global variables being declared. Basically, most of them are to capture and monitor the state of the different switches and conditions. So if we go down, the pin modes are specified in the setup loop, and then the more interesting part is in the loop. So at the beginning, we capture the state of the 2 switches by digital reading them. And then we also capture the state of the potentiometer and record that as motor speed. Down a little bit further, we first determine if this is a rising edge or not. So basically, if this is a new state for this cycle through the loop, or if it was already in that state. If it is a new state, and if the button has been depressed and it's high, then we invert the variable motor enabled. Exact same thing for the motor direction pin. We determine if it's a rising edge here, and make sure that it's a different state, and then we make sure that it's high. And then if it is, we invert the motor direction variable. Down a little bit further, we then take those variables, the motor enabled and the motor direction, and use those to control our control pins. So for motor direction, we set it one way, high and low, for control pin 1 and 2, and we invert it if it's equal to 0. And then for motor enabled, if it's 1, we set it to the motor speed, and if it's 0, then we just set it to 0 or turn it off. And then at the very bottom, we capture the current states as the previous states, and then it all starts over again. So I'll show you the circuit. So here's our H-bridge, here's the potentiometer and the 2 switches. This one, I believe, controls turning the motor on and off, so if I depress that, turns it off, and then my potentiometer controls the speed. If I press this button again, it will turn the motor off. So now, if I'll just turn it on again, and then if I press this button, it should reverse the direction. You can see that. So, works very well, and we can control the speed in either direction. Thanks for watching.